Hi, everyone. Welcome, and thank you so much for joining us today. My name is Jeff Chapman. I'm the Content Marketing Manager at InOrbit, and I will be your MC for today's webinar. Just a little bit of housekeeping this morning before we get started. Today's webinar is, of course, integrating RobOps, that's robot operations, into last mile logistics, leaning probably a little bit more heavily onto the role of automation in last mile delivery. If you're unfamiliar with InOrbit, we are a secure, cloud-based, robot-agnostic hardware operations and data management robot platform. We help robot manufacturers and their operators develop, orchestrate, and operate smart robots at a global scale. Central to what we do is, of course, a dedication to effective robot operations. So definitely a critical element when you're talking about any kind of a rapidly evolving robot sector like last mile delivery has seen. Few little notes. Today's webinar will be 30 minutes. We will be recording it. So if you guys have friends who maybe or colleagues who didn't get a chance to attend, keep an eye out for a link. We'll send that out after the show, and you'll be, of course, welcome to share that with them. And we will be taking questions at the end, the last 5 to 10 minutes of this webinar. So if anything comes up that you're interested in learning more about, please don't hesitate, type it into the chat, and we should be able to address that at the end. With that said, I think it's time to introduce your host for today's webinar. Please join me in welcoming the CEO and founder of InOrbit, Florian Pastoni. Hey, Florian. Hey, Ignacio.
Hey, Jeff. Thank you much for that intro. Sure. Let me just first welcome as well Ignacio, our guest speaker for today. And Ignacio has made a career defining how data and autonomous infrastructure is shaping the last mile delivery sector. And he's the CEO of Tiny Mile. They're a Toronto-based robotics company. And they're also the creators of Jeffrey, which is this adorable semi-autonomous last mile food delivery robot. So we're very happy and lucky to have you, Ignacio. Why don't you kind of share a little bit about your background and how you got started on this?
Thank you, Florian, and thanks for having me today. I'm a big fan of InOrbit and you, and so I'm very excited about this. Yeah, a bit of my background. So I moved to Toronto to work in autonomous cars. I was part of a company famously known for actually killing a pedestrian in Arizona. And that was some of my realization that what the media was saying about having autonomous cars in the near term wasn't as true. And I saw an opportunity in delivery robots, especially lightweight delivery robots that can move on sidewalks, walking at speed. That sort of makes them inherently safe. And there's a big opportunity, of course, commercially. And so that combination was very attractive to me to start this company.
That's fantastic to get everyone up to speed. If you can maybe help me paint a picture of the current state of last mile delivery. What do we mean by last mile? And I know it's been growing very rapidly, and obviously the pandemic was a factor in that, but it had happened before that. But there are very different approaches to it. So maybe set the stage for us.
Yeah, so last mile is of course, massive problem. And so I guess I'll do two categories. So one is when you buy, maybe you can divide this in hyper efficiency and hyper speed. And so hyper efficiency is when you want shoes, you don't really care when they come to you. And so these are sent in a container ship from China. And given that you're sending so many containers at the same time, it's really low cost to send them, and they sent in a truck. And so you have a driver who's driving an entire container with millions of shoes to you. And so it's only a few cents to do that. And then it comes to the last mile, which is this person who take it out of the truck and have to go to your door, can knock on your door and make you sign it and so on. And so that part is just one box that he's doing. And that takes a few minutes. And so that costs a good chunk of the entire trip. And so if it costs, let's say, $10 to bring those shoes from China to your home, maybe it's just the last mile, it costs you like $5 or $6. And so
it's 10,000 miles plus one in that case.
That's exactly right. And so that's kind of the hyper efficient category. And then you have the hyper speed category, which is when you want that pizza that you really like, when you're not feeling like cooking that night, and you actually want it delivered to you. And so that is, it's just the last mile, right? So you need a person picking it up and saying to you, and you really care about hyper speed there. You want that to be done in 10 or 15 minutes. And so with the advancement in robotics, now we can try to automate this last mile and reduce cost fundamentally. And as you said, there are many different approaches being pursued right now. So there's people working on drones, there's people working on road vehicles, and then there's companies like Tiny Mile working on sidewalk robots. And we all like to pretend that our approaches will dominate the market and satisfy all of them. That is actually very unlikely. And so for different distances and for different geographies, there are solutions that are better. And so Tiny Mile and our sidewalk robots are the best solution for very dense cities. And so we're based in Toronto, and deliveries here are very short distances. People order bubble tea 400 meters away. This is actually very common. And so when the distance is so short, having a very low-cost robot that can move in the sidewalk, it's very difficult to park in a city like Toronto, and there's a lot of congestion. And so road vehicles are really not a good solution, and sidewalk robots are amazing. When you're in suburbs, and your delivery distance is like 10 kilometers, and you want these hyper speed, and so you want something to be delivered in 15 minutes, then you need to move at 40 kilometers per hour. And of course, you can do that on sidewalks. And in suburbs, there's usually less congestion, it's easier to park and whatnot. And so these road type vehicles are great solutions for suburbs. And if you live in rural areas, when you don't have good road infrastructure, it will be, of course, impossible to have a sidewalk robot there. It's just it couldn't handle the terrain. It's just easier to go in a straight line and have a drone, and there's plenty of space to park the drone safely in front of your rural house. And so drones are a great solution for that, the longer distances in the rural areas, and a terrible solution for cities.
Right. So, I mean, you mentioned last mile, which at least for those of us metric system, it makes sense. Otherwise, it's a little awkward to say the last 1.6 kilometers. And you said one of my favorite words, which is pizza. So maybe talk about pizza or food in general. I think we all want our pizza delivered quickly. And from what I understand, there's a lot of environmental benefits to some of these new delivery mechanisms compared to, let's say, somebody driving their own car. But we've also heard a little bit of pushback on sharing the roads or the sidewalks with autonomous and semi-autonomous vehicles. So what would you say, both for the consumers and on the supply side, what are some of the benefits that you see here?
Yeah, in this case, every technology has an impact, and so we need to deploy technologies that have a very big positive impact and small negative impact, right? And I think delivery drones and robots is one of these cases. And so the first impact is, let's say, on safety and on pollution. And so in a lot of the traffic in cities is really to deliver things. And in a city like Toronto, there's 60 deaths per year, and there's thousands of injuries. And so if you can replace some of these traffic of cars and trucks and for small robots that are inherently safe, that's a huge win. Then pollution is a big problem. And so the last numbers I've seen is like 27% of pollutions in cities is because of last mile. And so if you can replace, again, these big trucks with tiny delivery robots, that's a huge win for the environment. And then economically, it's also very important. And so transportation is really the backbone of the economy. That's why governments spend so much money in highways and all this stuff to improve transportation. Basically, if you can decrease the cost of transportation, then the entire economy benefits. That's exactly what we're doing. So we've been able to decrease the cost of delivery about 10 times. And this is very meaningful. For example, the amount of people working just on the food industry is immense. So something like 1 in 5 young adults work in the food industry. It's like 2 million people in Canada. And most of these businesses are struggling right now. And so they usually make between 5 and 8% commission, 5 and 8% margins in sales, but they have to pay like 30 or 35% commissions on delivery. And so that's a huge amount. And so we've been basically able to lower that from 30% to 3 or 4%. And so that really increases the margins. And so you can make this business sustainable. And so there's so many positive things. The little negatives one is like, sure, we need to occupy some part of the sidewalk. But it's not this terrible case with the scooters that were piling up on the sidewalks and whatnot. This is basically, the road is the same size as a person. And there's like hundreds of thousands of people walking on sidewalks at any moment. So just adding in a few thousand robots like doesn't really increase congestion on sidewalks meaningfully. And we can try to take the sidewalks are less occupied and so on to try to mitigate this.
So I know for different modes of last mile delivery, there are different, but regulatory. You touched on the kind of geographic and environmental challenges, but also a lot of technical challenges. So, for example, for drones, there's the FAA to contend with. So, can you share a little bit more about what you're facing in your specific area? And maybe get a little geeky on some of the technical challenges that you had to face.
Yeah, well, the important thing is that this is inherently safe. And so what we really don't want to have is any accidents at all. I have crashed a robot in my leg multiple times, and it really feels like a dog jumping on you or something. It really weighs about 15 kilos and moves at walking speed. And so it doesn't cause a bruise or anything. But we of course are paranoid. We don't want anything like this to happen ever. And so we spend a lot of time in having really strong collision avoidance that works well either if it's raining or snowing or dark and so on. And so we spend a lot of time in safety. And so the regulators see something that's inherently safe, a lot of work from professionals in safety, and then all these benefits. And that's why they see very positive about this technology. So even though it's early days, the upside is so big that they're very proactive and already passing positive regulations. And when you speak with our customers, they're also super happy. So again, restaurants are struggling. Something like 8 out of 10 borrow money in the last year. Only 1 out of 10 is making a profit right now. And so these are people that really need help. And they're sort of like complaining to the government to support them, to try to cap the commissions on delivery and so on. And that's a bit difficult for the government to do. They've been trying to pressure the big food delivery companies, but it's not, they have cost, right? And they're losing money as well. So it's not something they can do. But by using this technology now, they can really meaningfully and sustainably lower the cost. And so there's excitement in the regulators.
Can you maybe share a little bit more about the technical challenges that go into having robots out there in the wild?
I mean, these this better than me, right? It's and that's why a big fan of InOrbit. And so supporting the infrastructure needed to support these services is far from trivial. Like it really takes an army to build everything, to monitor where the roads are, to manage all the orders and the state of all the orders and so on. And so hundreds of hours of engineering really went into all this infrastructure. I guess you can divide the challenges in the robot itself. So we have, of course, hardware that has to be built. And so it's something very difficult that we had to do is making the robots the battery last 20 hours. so that we can just release them in the morning and then having them do deliveries all day. And so a lot of mechanical and electrical engineering to do some of that. Then there's all the challenge in having the robot drive itself and having the collision avoidance and so on. And so that's very difficult, of course. And then you have this part which is mostly what InOrbit supports, which is tracking the state of all the robots and basically all the fleet management and so on. And so something I would love to ask you in later on is totally hear how you guys are supporting all this robot management, which is far from trivial, of course.
Yeah, absolutely. I hope my connection is good enough for people to hear me. Yeah, I think some of the things that you mentioned are things that we're seeing across applications in robotics, anything from battery management to navigation. There's a collaboration that can occur between people and robots to make this more scalable. So I think part of what we try to do at InOrbit is to bring all of that underlying infrastructure that's shared across companies and make it more easily available, and basically allow companies like yours to focus on the specific problems that you're trying to solve, which are daunting in their own right, and not have to worry about some of the shared infrastructure. And increasingly, what we're seeing is the need for orchestration of some of this, right? So, for example, in a warehouse, you may have robots that are moving, large boxes, but you may also have robots that are cleaning the floor. And while we haven't yet seen this in open spaces like in cities, I think that's something that is likely to come in the future. And there's some discussion about, people have been talking about smart cities for quite some time, but I think now with robots like Jeffrey, you're starting to see the smart city come to life. So I think that's pretty exciting as well.
Yeah, I think here's where I see like so much opportunity in the future. If you want some analogy, when we're trying to start internet companies in the past, like you have to build your servers and you have to build all this infrastructure, and that was like so expensive and so time consuming. But right now, with all these frameworks that we have and AWS and all these, you can build software companies very quickly, or much quicker and for much less money than before. And robotics until now was sort of the same thing. If you want to do anything robotics, you have to spend tons of money and tons of time building your own hardware, building your own orchestration software that is super time consuming and super difficult. But with InOrbit and some open source hardware right now, you can really focus on the application, really what creates value, and do this much cheaper and much faster.
Absolutely. So today we're technically in December already. So it's we're getting to the time of the year where we ask people to make predictions about the next year. So maybe looking at the next 1 to 3 years, what do you see happening with last mile delivery, and
Yeah,
maybe in cities, but also in the broader sense that you described before?
yeah, I do think that I really see that this is inevitable. That I'm old enough that I remember that when we didn't have phones, like cell phones, and then a few years later, everybody had a phone, and it was hard to imagine a past without them. And so I think delivery robots is the same thing. It's going to be very weird to think that in the past we had people doing these deliveries when we could have a machine doing this for cents. And so delivery robots in cities, and then cities, that's sort of like the first like widespread application I expect, because it's sort of like the one that's incredibly safe and easier to scale. And so that's really what I imagine in a couple of years from now. And then following that, it's sort of like road and drones at the same time.
Perfect. And I think we only have a few more minutes before we open things up for questions, but let me go with one more aspect, which is the human in the loop aspect. So how do you see that playing in this space?
I do think that's sort of the right way of building any robotic service these days. And so there are certain tasks that are very easy to automate and that machines can do better. There are certain tasks that are very difficult to automate and that you need humans. And so being able to combine machine and human intelligence well, so that you can deploy these services at a very low cost, I think so that's the way forward. And so I'll give you some examples. So a lot of what our robots do can be easily automated. And for example, the path that the robot does on the sidewalk, that's like relatively straightforward. But once in a while, you have these systems, these problems in which you have, let's say, a police tape on some area that you shouldn't pass. It would be very difficult to train a machine to identify that, understand the meaning. By combining both human and machine intelligence, we can decrease the cost of delivery quite a lot because these cases are very uncommon. And so, and this has applications to so many areas outside delivery. And so I encourage people to just seeing things binary as being manual or being fully automatic to really try to find sort of like middle point and make the service work reliably, but at a low cost.
Wonderful. I totally agree. All right, so I think at this point, I would send it back to Jeff, and he's going to be able to ask some questions.
Sure, there I'm unmuted. Okay. Yeah, no, it's fascinating. It's really interesting. Actually, I'm just a quick step back, just for some context. Is there an impact that sort of it's evolving so quickly that the sort of the mid-mile around the the autonomous long haul trucks, we all know that it's already happening. It's obviously like a scaled level of additional complexity when you're talking about translating that into last mile, but does the growth of that field, how does that impact, since it's so related to the delivery as a whole?
Yeah, so some people have this idea of the mothership, so something doing the middle mile, and then the package is somehow going from that van or something into the robot, and then the robot in the end, or this mothership carrying the robot, and then the robot dispersing. I imagine that would work eventually. It sort of adds some complexity.
Right.
And so the question is basically, imagine you were to do, that's of course a use case for the hyper efficiency, not for the hyper speed. And so if you want to do hyper speed, you probably just want to have one road vehicle going directly very quickly. If you want to, again, carry these shoes from China and then you want to put it on the truck doing the middle mile, and from there, tons of delivery robots distributing them, I imagine that could work. I think it's a matter of time until we start seeing these collaborations. I haven't seen too many companies sort of working on both at the same time. Let's say I've seen middle mile companies and last mile companies, but these I think it's just a matter of time until things start working together. I'll give you another example, which is so a bit unrelated, but it's collaboration that we're doing with some other company. So there's a company that has a robot that's making food now. And they can make very healthy food. So it's like a very complex vending machine. And so we're integrating them with our robots. And so at 2 a.m. when you want some food, instead of choosing McDonald's, which is not super healthy, you can get something very healthy from this vending machine, and it's going to be put on a robot and then delivered to you. And it's going to be faster than McDonald's. It's going to be cheaper, much cheaper than them, and healthier.
Right. I think like what you said, it's going to probably be a patchwork. It's going to be a collaboration, which obviously is something that we're very interested in, that whole like intra-logistics process, start to end, because it's not just there's not just one part of it. There's a whole sequence of events that need to take place. So having different companies and different kinds of autonomy working together is going to be critical. Absolutely. Yeah.
Agree, and that's not easy to do, and we don't have. We need someone building the infrastructure to connect these kind of companies, because it's not super trivial. At some point, we need to connect the arm from this vending machine into a robot, and so we need some common software to make that happen well.
Right.
And so yeah.
So that said, do you think that there is any major area that's being overlooked by the sector as a whole, or is it difficult to say because it's so disparate still with so many different approaches? Sorry, I'm going off of my questions. I'll find the audience questions in a moment.
These I think there's like so much opportunity right now, and so I think I like the internet as an analogy, because it's like once we were able to make the movement of bytes very low cost, then so many companies were built on top, and so many companies that the people who created the internet wasn't even thinking about. And so now robotics is becoming to the point in which it's very easy, or it's becoming easier, thanks to companies like you guys and open source hardware and so on, to build applications. And it really seems like there are no limits on this. And so, for example, we release an API now so that anybody can use our robots to move things in cities. And we get emails every day from people who want to use it. And so many ideas I never even thought of. And so one idea someone proposed the other day was to do some sort of code check. So it's this app that before you enter the bar, you press something on your phone, and then you put your code inside the robot, goes away, then you press again, it comes back. I never thought of that. And we're getting so many applications on sharing things, so book sharing. And so you don't need to buy the book, but whenever you are in a reader, you press there, and 15 minutes comes to you, and you can have it for a few days. It's like all these things that you can enable. And so there seems to be basically limitless. Some other interesting things is sort of like reusing cutlery. And so the restaurant ships you a nice plate and a metal cutlery and so on. And so if you washing it, you put it back on the robot, and then gets reused. And so it really seems infinite how many things you can do. And that's just by moving things in cities very quickly and at very low cost. But when you think about the totality of robotics, I think it's really, I think we explored less than 1% of what can be done.
Oh, that's fantastic. That's really cool. But those other applications are just great. I'll have to explore that API definitely. So I do have a question here. That said, so what's the next step? What's the next hurdle? What's the next challenge for TinyMile to overcome?
Yeah, so we are growing. The company now is 15 people. So we're actually growing now to 50 people. And so we're really hiring on all areas. And so the plan is to go to as many cities as we can and to offer services. So it's really, the big challenge for us now is scaling and growing. We have a product that works very well, so we can do deliveries on time consistently, 10 times cheaper than human couriers, and very happy customers. And so we need to put more robots. That's a challenge.
Oh, that's great. I had one more really quickly, if we can just go for 1 minute. Florian, this one is for you. How important do you really see orchestration of robot fleets as this space grows?
Yeah, I think that's definitely coming, and we've seen it in other areas. One of the benefits we have at InOrbit is because we work across all of these different applications of robotics. We start to see some of these trends emerging, and increasingly we're seeing needs around interoperability and orchestration. And it starts with just not getting in each other's way. So we'll call it peaceful coexistence, all the way to coordination, like some of the cases that Ignacio was talking about, where you may have one robot that's making food and then another robot that's picking up the food and delivering it. So those are all examples of orchestration.